Welcome to Study Loop.
Problem 7.23. So we have a block that's not attached to this spring being compressed against it. The spring is fixed to some sort of fixture, and then the frictionless air table. The spring constant is 25 newtons per centimeter, and the spring is compressed by the block until 11.5 joules is the potential energy stored. So we want to find what the maximum speed and acceleration are, and at what points in this process they occur. So, part A, Vmax. So the only thing doing work on the block is the spring after it's released. And so by the conservation of energy, we know, and it's released from rest, the final kinetic energy is going to be equal to the initial potential energy. And this is just given. So 1/2 mv squared is equal to, and the spring after this is released from it has no more potential energy, so the final potential energy is entirely lost, entirely converted, I suppose, into the kinetic energy of the block moving across the table. So then V is equal to the square root times this potential energy divided by the mass. And then this is 3.03 meters per second. Now this happens when all of the potential energy has been converted into kinetic energy, and so this happens when the block leaves the spring and is the speed forever after that, because it will move at a constant velocity because there's no friction. But the first point in time when it achieves this speed is when it, just as it's leaving the spring. So when block leaves spring. B, so we want to know the acceleration now. We know that acceleration is equal to the force divided by mass. And so when the spring is compressed all the way will be its point of maximum force. This will be kx, and it will be divided by the mass. And we also know the value. In order to know x, we know a value for ui. It is 1/2 kx squared as well, and so then the x in question over here is the same as it is here. So it's the square root of 2u I divided by k. So we can just substitute that in here, or you can find what the value of this is and then put it in here, whatever you like to do. And then we find that it's 95.9 meters per second squared. It will start decreasing immediately because the force is proportional to the compression, and the compression decreases continuously from the moment that the block is released. And so this is right after the block is released. Write a little more legibly here for you.